No, I know, but it's still. I mean, I know you guys are busy as all get out.
Hate mail from me or anything.
Oh, I'm used to it. What do you think I got all weekend? Now, friends, yeah. You do realize the rainy day coupon is a benefit to you to buy you 24 hours. And the inconvenience of getting into town, I totally get what you're saying, but that's part of the, but I got 24 extra hours to do it. You could also knock it out while you're in class. You can turn it in later that day. It gives you within 24 hours to turn it in. You can do it before you go home that day that you're here, stay an extra half. Again, the idea of it is that it buys you time. I mean, I totally get what you're saying. I get what you're saying. But you don't have to wait 24 hours. You don't have to bring it back the next day. You can bring it back later the same day.
And instead of getting a car to drive across town, I have to pay for an extra hour babysitter.
What I'm saying is, the idea of that coupon grew out of a student idea. It would be really cool if we had some way, if we miss a due date, to turn something in late. I said, sure, that's great. But making it be, I'm not saying it's always convenient. I'm saying that that's the way, the iteration that it's in right now. And I've been pretty good with working with people in exceptional circumstances, except I need to kind of hear about them beforehand rather than hearing about them in class, because then I can't deal with them at all. So, okay, last time, I know it's been a few days, I had you guys do an in-class quiz where you were gambling with dice. The idea was winning starbursts or not winning starbursts, and I get that. We ended up, and I think the quizzes are right there in a pile. The quizzes are right there in a pile. Like I said, I didn't know how to give them back, to because there are multiple names on each one. I did record the grades in the grade book, so you guys have your proper grades in there. But what we came up with was in the game of Chuck-a-Luck, our average, they're so tight, our average winnings per game were, I'm going to check this, I think it was negative 0.4 starbursts per game. No, negative 0.6, excuse me, negative 0.6. Negative 0.6 starbursts per game. Now, what does that mean? What does it mean to average negative 0.6 starbursts per game? What did that mean? And I know you have to think back to Thursday because it's been a few days since we actually did this little activity. What does it mean to have a negative average?
We gave up 6.
You gave up 6 out of the 10, exactly, which means you started off with 10. I walked around and gave everybody a pile of 10 to gamble with, and every time you gambled, you had to put one into play, your ante. And then you roll the dice, and you either won or you lost your ante based on how many of whatever number you bet on you rolled. Perfect. The fact that it's negative means you were down from what you started with. Most of you ended up, the idea of an average is, on average, typically, most of you ended the game with 4 when you started with 10. So over the course of 10 games, you lost 6 starbursts. You lost 6 starbursts over 10 games. You lost 6 starbursts over 10 games. Now, the idea of the game of Chuck-a-Luck is that it exists in Vegas casinos. These games exist in Vegas. Craps exists in Vegas casinos. Chuck-a-Luck exists in Vegas casinos. All these games exist in Vegas casinos. Why do they exist in Vegas casinos? Blackjack, for example, and poker, and one-armed bandits. And forget poker. One-armed bandits, Chuck-a-Luck, roulette. Why do those exist in Vegas casinos? I'm hearing lots of things said exactly the same, they're saying the exact same thing in different ways. All of these averages are negative on those games. Some are more negative than others, but they all end up being negative. And if it's negative for the player, that means it's positive for the casino. That's the idea of this. If it's negative for the player, that means it's positive for the casino. So the question I have is there a way to have figured out this average that we figured out in class together by playing the game 300, 400 times? Is there a way to figure it out without having to actually play the game and bankrupt ourselves to find it out? And the answer is yes, of course. But the point is that I wanted you to play the game first. A, to get you sugared up, of course. But B, to see that that's not the best way to learn the average. Because in order to learn that the average was negative 0.6 per, you had to actually lose quite a bit of resources to do that. So what we need to be able to do is to attack the idea of this average winnings per game from a mathematical point of view. And we're going to see by the end of the day how this ties into insurance rates and things like that, how much you guys pay for, say, car insurance or life insurance or things like that. It all bases on the exact same idea, the idea of this average. Do you remember the average we did at the end of class on Thursday? After your exam, turn your exam in, and then we crunched an average on the board, a couple of them actually, a couple averages on the board. Do you remember? What average was it? GPA. It was your GPA. What kind of average did I keep calling that? It was a weighted average. Why were they called weighted average? Why was it called a weighted average? Go ahead, Gabe.
Because of the credits?
Good. The credits had certain data counting more than other data. The same thing is going to happen here. The same exact thing is going to happen here. What we're going to look at today is we're going to see, go over here, we're going to look at the idea of a weighted average, with respect to something called mathematical expectation. And this idea, I put mathematical expectation in quotes, because the idea of the quotes or a mathematical expectation is it's how much you can expect to gain from a given scenario. How much can you expect to gain from a given scenario? And the idea of this is you can calculate how much you're going to expect to gain without actually having to participate in the game. So how much are you going to expect to walk away from playing Chuck-a-Luck? Assuming you step up to play it. You can actually calculate this based on how the game operates and how the probabilities of the dice fall. So what I want to do is, I want to look at last Thursday. The idea of a GPA. The idea of a GPA.
Did you say what the WRT was?
With respect to.
Oh, thank you.
With respect to. So if you think back to last Thursday, we set up a couple GPA calculations. And the basic setup, I'm going to go basic setup. You can look back at your notes and also the videos to see the actual interplay of the mathematics here. The basic GPA calculations, you had your grade in each of your classes, so A, B, C+, whatever you had. And then you had a second column for credits. And 1, 4, 3. And these can be whatever they are. I mean, they can be whatever the different classes are, the different weights, the different grades. And we spent a great deal of time, like about an hour or so, actually crunching these GPAs out in class last time. We're going to see a corollary to that in the world of mathematical expectation. Instead of a grade, we're going to see a column that's called payout, which means what are the different ways you can earn income? And I'm going to put earn income in quotes. Actually, we should put payout in quotes. Because sometimes you pay out, and sometimes the house pays out. Sometimes you pay out, and sometimes the insurance company pays out. So there's this idea of money changing hands. But payout very often means we're getting money from something. It could also be that you're giving money back to something. So that's going to correlate to the grade column. And then the credits column, which correlated to the weight that you guys were talking about, are going to correspond to probabilities. Now, all we've got to do for any particular example we're looking at is figure out all the different payouts and the different probabilities, and then analyze this the exact same way we analyzed Chuck-a-Luck, or excuse me, not Chuck-a-Luck, the GPA on Thursday. If you remember what we did on Thursday, and of course you could say no, because it's been 5 days. If you think about what we did on Thursday, we analyzed the grade as a number times the credits, plus the grade times the credits, plus the grade times the credits, plus the grade times the credits. We summed all that up, and then divided by the sum of the credits. And that's the way, exactly the same thing we're going to do when we analyze Chuck-a-Luck, and then we later analyze, insurance rates. Because insurance rates basically operate on a function of gambling as well. And you'll see why it's gambling momentarily. Okie doke? So let's think about Chuck-a-Luck. Let's think back to Chuck-a-Luck. Do you remember the basic gist of the game of Chuck-a-Luck? How many dice did it involve?
2.
3.
3 dice. Love it. 3 dice. Swing over to here. 3.
For what number?
That's
Yeah.
8.
32. 7.
Chuck. Luck.
4.
So there were 3 dice. What were you betting on?
One number.
One number of the 6 that are on each die. How much did you win each time, and why did you win this each time? Suppose you bet on 5. Suppose you bet on 5, the number 5, and you rolled 2, 3, and 3. You should have bet on 3, obviously. But what do you win if you roll 2, 3, and 3, and you bet on 5? What do you win? You win nothing. You actually
You lose your ante.
you lose your ante, you lose your dollar. Thank you, Holly. You lose your dollar. So you're actually $1 in the hole in that respect. Let's start a little list going. So let's say you bet on 5, on 5. And 5 could be 4, could be 6, could be 3, could be 2, could be 1. Doesn't matter to me what you bet on. Okay? So you bet on 5, and you get this many 5s. Now this column isn't going to be part of the computation of our expectation, but it'll help us keep track of how much money is changing hands each time. So you're either going to get no 5s, 1 5, 2 5s, or 3 5s. That's the number of 5s you could get. And this could go with any number, like I said, any number at all. Okay, so we're going to put a payout column here. Okay, let's say you didn't roll any 5s whatsoever. What's your payout? -1. It's negative because you lost $1. Now you can also look at this from Vegas's point of view and call it +1, because +1 is is them bringing in $1 every time you lose. But let's play it from our point of view, if that makes sense, Cheryl. Because in our we bet $1 to play, so we're already $1 in the hole. We're already $1 in the hole. So you got a -1 right there. Fantastic. Okay, so let's say you bet on 5 and you roll the 3 dice, and you got a 2, a 5, and a 4. Right? What do you win then? You win. Good. I heard 2 correct answers. You win 1 back, but since you paid 1 to play, you break even. You break even, and the payout then is essentially 0. This is in dollars. Does that make sense? Because you have to pay the $1 to play, which means when you win 1 back, you really don't win 1. You end up breaking even with 0. There's no money has changed hands essentially. Kind of, sort of. Okay, so you bet on 5. And you roll 5, 6, and 5. What do you win now? You actually clear $1. You're starting to remember this now. You actually clear $1. You clear $1 because they give you 2. But you still paid 1 in the long run you paid 1 to play. You win 2 back, so you end up clearing 1. And let's say you bet on 5 and you roll 3 5s. 5, 5, 5. Remember what it was? It's actually much better than that.
Oh, yeah.
It's 10-1 payout, but Kate, it's 9 because you have to offset the 1 you already played. So each of those numbers represents losing the $1 by playing the game. -1 is 0 minus 1, 0 is 1 minus 1, 1 is 2 minus 1, and 9 is 10 minus 1. And that's how they can advertise and get people to come in and play the game. 10-1 payouts. 10-1 payouts. That sounds pretty good. Especially if you bet $100 and you bet on 5 and you roll 3 5s. That's fantastic. What's the problem with reasoning like that? What's the problem with reasoning like that? This is a great investment opportunity. I got 10-1 payouts, right? I got 1,000% interest. I'm going to put all my money into this and play, and I'm going to go to, not quintuple, I'm going to double quintuple. I guess that's like 10 times. What's the problem with that logic?
On average.
Boom! What happens on average? So what we need is we need to analyze these payouts. We now have essentially A, B, A, C plus. We've got these great grades, right? A, B, A, C plus. So we're like over here. And I've just asked you, what's your GPA? What's your GPA? Okay, what's the problem with me asking you that question right now?
Doesn't know credits or
We don't know what the credits are. Can you just average those 4 numbers together? I mean, you could. And if you average those 4 numbers together, what would you get? Looks like about. Go ahead. Average it. Average those 4 numbers. Roughly 2, 2.25, right? If you add those four numbers up, then 1 and the negative 1 cancel. 9 divided by 4 is 2.25. That sounds pretty good, doesn't it? That sounds like you make $2.25.
Make more noise.
Oh, Jesus. Sorry!
No, leave it open.
Sorry!
That's how we do it here. I'll take my shoes off.
See, right in my style. Let's tell you guys. Right in my style. Barefoot hippies start taking peace pretty soon. Oh, yes, it is. Anyway. That's all we do now. Appreciate that. The problem is, if you average those 4 numbers and get 2.25, that makes it sound like you walk up there, and instead of handing them $1 to play the game, just walk up with your hand out. And go, I'll take my $2.25 now. And they say, what? I was like, well, if you average the 4 payouts, it averages to $2.25. So let's save everybody a lot of trouble. And just give me the $2.25 now, and I'll walk away. Good luck with that, exactly. Well, actually, honestly, you could do this with any Vegas game. Suppose, well, we'll come back. I'll come back. But what's the big problem with that? Does this game have a positive average? According to what you guys did in class, it should be negative. So why are we getting a positive average over here? Because we didn't. Say that again, Cheryl.
You've got an outlier. You got to
Define this as what is this outlier talk she's using back there? Outlier. I love this, by the way. What do you mean? What is the definition of an outlier? What is an outlier?
It brings the average up,
Using fancy words.
but it doesn't happen all that often.
That is the best definition of an outlier. There's a great book by Malcolm Gladwell called Outliers. If you get a chance, some of you may have read it. Yeah, I think so. Yes, that was brilliant. Golf clap. The idea of an outlier is something that doesn't happen very often. When you average -1, 0, 1, and 9 by adding all 4 of them up and dividing by 4, what assumption do you make when you do that? That each of these 4 things happens equal amounts of times. That you get 3 5s just as often as you get no 5s, just as often as you get 1 5, just as often as you get 2 5s. Is that true? It doesn't appear to be true based on what happened in class on Thursday. Did anybody get 3 of anything they bet on? It didn't happen at all in class. It usually happens once, well, you'll see, it usually happens once in roughly 200 to 300 trials. You'll see why momentarily. I've got a simulation to run for it. So in other words, Cheryl, yes, you hit the nail right on the head. We need to compare and contrast our distribution here with the GPA distribution, but we need, if you will, the credits column. We need the credits column. We need to know how often we should count the data. So I love the word outliers. So the question I have for you guys is, what should we apply? I'm going to call this column probabilities. Only because I was going to call it something different. But you guys seem to like the probability idea from the exam, so we're going to stick with that. So if you had to assign probabilities to these 4, what do you think the percent occurrence of them is? How often do you think you lose your ante? Give me a number. How often? 66% of the time. Roughly 2 and 3 times. I love that. So we're going to call that roughly 2 and 3. I'm going to put, if you don't mind, guys, I'm going to put a guess column over here. No, this is good. Let's put some guesses over here. Okay, I got 2/3. Anybody else want to edit that one? We'll stick with 2/3. We'll see how close these come. I've got a mathematical simulation that'll actually crunch the numbers for us momentarily. 2/3 a good guess? Fair enough? Okay, how often do you win your ante back? What do you think? We'll call that 66% just to make the addition easier later. How about winning your dollar back? How often does that happen?
1 and 2.
1 and 2? Well, the only problem with that is that now you've added up to more than 100%.
Right.
And you can't do that. Whatever these are have to add up to 100%. So this is a little too high. So we either have to make that one lower or this one high, and this one lower, or both. 33%? 33%? Now we're at 99%. That's good. But that means we have to split the remaining 1% here. And I got no problem with that. We could do it this way. We could call this one 0.01 and say that this never happens. We could say that, although it can happen, can't it? It can happen. You can roll 3 5s. We just didn't on Thursday.
Do we have like 1% that did get?
I don't think, what, I don't know. I asked a couple minutes ago, people said did anybody win on 3? You bet on a number and then roll 3 of that?
No, maybe we can have a different.
It can, but Harmony, whether or not we got it, it can happen. So, but this would be, if you will, a proper assignment of the probabilities because they sum to 100%. You guys buy that logic? They sum up to 100%, and that's kind of what you want. You want, oh, let's not use Greek symbols. Let's put sum. They have to sum to 1, which means 100%, and it has to sum to 100% because 100% of the time, one of these 4 things is going to happen. Although clearly we have to adjust 0. 0 can't be 0. It has to be something because it can happen. So the question I had is, how could we get values for these probabilities? Well, one way we could do it is I could take those quizzes that you guys got, and I could go through them right now for about half an hour, or make you guys do it, because I'm all about slave labor and mathematics. Kidding. And make you guys keep track of how many times you got 0 5s, 1 5, 2 5s, and 3 5s, and then make a ratio of the total number of trials. Or we could do what people do in the 21st century, which is use a computer simulation model to do it. So what I'm going to do, I'm going to pause this.